Alrighty, so a quick reminder about this next section that we're going to come up upon, okay? Just a quick reminder that it's all about that base. Now, I know you're going to be slightly disappointed that you're not watching the YouTube video, but that's not going to be a thing. So you're welcome to watch it on your own time, but I just wanted to do a quick refresher course on how to do prime factorization. A lot of us still seem to really struggle with this, how to rewrite just any old number into an exponent. So again, our goal is to be able to write every number into an exponent. Okay, that's our overall goal. How do we do that? How do we accomplish that? If I were to give you the number 8, how could I rewrite that into an exponent? A lot of people wouldn't be able to just by me giving you the number 8. So let's talk about the process that we would go through. The first thing we would do is we would do the prime factorization. I really encourage you to do this over on the side of your paper, not like in the middle section. Sorry, that's a Z. I do my Z's funny. So first we're going to do prime factorization. So I'm going to take that 8 and I'm going to rewrite it maybe over here in the margin somewhere. Little tiny 8. And I ask myself, what times what is 8? And we all know our times tables. So 2 and 4. Now, why did I circle the 2? Because 2 is prime. No other numbers besides 1 and itself can go into it. Oh, 4, but I can break 4 down further. 2 and 2. 2 is still prime, so I'm going to circle that. So I know that I can rewrite 8 to turn it into a couple of 2's. How many 2's multiply together to get 8? 3 of them. We count up how many circles we have. So I would say 8 is the same as 2 to the 3rd power. I could do the same for another number, such as, oh sorry, I should write my steps. So we did the prime factorization, and then 2, we rewrite with the new base. And it should be always a prime number base. I shouldn't have the number 4 or 8 or 16 as a base of an exponent because it should always be in prime factored form, which is the simplest, most farthest down that I can get a number to go. In this case, it's 2. Let's try it with another number. Let's try, 81. Now I know some of you are probably thinking, well, 81 is 9 times 9. And I agree with you. It is 9 squared, or 9 times 9. But there's actually a little bit more to it than just that. What we need to do again is we need to do our prime factorization. I'm going to come over here to the margin. 81, like you just said, it breaks down to 9 and 9. And then we can actually break down 9 even further to 3 and 3. 3 is prime because only 1 and 3 can multiply into it. So we circle it. And how many 3's do we have? We have 4 3's. So my base is 3 and the power is 4 because there are 4 3's multiplying each other. 3 times 3 times 3 times 3. So if I need to, I can rewrite it in 2 separate ways, but I pretty much always want to rewrite it into a base of 3. Now, the problems that we're going to be encountering today are slightly more complicated than this. You might have to change not only one number, but maybe 2 numbers. For example, you might have an equation today such as 81 to the x power equals 27 to the 3rd power, let's say. Now what I would do here is I'm going to do that prime factorization, but I'm going to do it for each of the 2 numbers. 81, we actually just did that, so I might just rewrite that like that. 81 is 3 to the 4th. And then over here I might do my 27. And I might ask myself, well, how do I get 27? I might look back at my times tables, but I do know that 3 times 9 gets me 27. And I break down the 9 again to get 3 and 3. So 27 is going to be rewritten as 3 to the third power. Now I have to keep in mind, there was already some stuff up there in the powers, weren't there? There's that x right up here, so that's going to get multiplied by this power, 4 times x, and then there was already a 3 up here next to this guy. And you can tell by the different colors, like that was my blue original equation. And then I converted the 81, just the 81 though. I didn't even touch that x. So the x has to come down and stay there. And then the 3 has to come down and stay here as well. And when I simplify this even further, I'm going to actually multiply those two together. And we're going to get 3 to the 4x power equals 3 to the 9th power. And then because we have same base, voila, we can just get rid of the bases because same base, which means if the bases are equal, the powers have to be equal. So then we can just rewrite it as just the powers equal to each other. 4x equals 9, divide by 4, and we have our final answer. X equals 9/4. Bam. But again, it's really, really important. The whole goal for this little tutorial video is to remember, take that 81, find the prime factorization, rewrite that, multiply it the power times the power, because power to a power means multiply, and then we're going to simplify and solve it all the way out until we solve for our x value and get that power out of the power, just solving for the x.